So now we're going to do another example of systems of linear equations. This is very similar to the previous one. And we're going to go through the solution step by step. Okay. So the first thing we do when we see a problem like this is, of course, we want to read this problem. So let's read it together. Suppose that 100 people go to a theater, and suppose further that the adult tickets cost $5 each and the child tickets cost $3 each. If ticket sales were 480, how many children were in attendance? So we can already see from the way that this problem is stated that this is going to be a system of linear equations. So that's just to get started. Okay, now what does this say? The first thing we're going to do is we're going to label what our variables are going to be. So I'm going to let A be the number of adults, and I'm going to let C be the number of children. Right? And so I recommend whenever you're solving problems, you always want to, when you're going to put in a variable, you always want to label what it is. Here, the A is going to be the number of adults, C is going to be the number of children. It says here that 100 people went to the theater. So we know that A plus C has to equal 100. Moreover, it says that the adult tickets costed $5 and the child tickets costed $3, and that the ticket sales resulted in money of $480. So that is $5 for every adult plus $3 for every child gives a total of $480 going to the theater. Okay, so we have constructed our system of linear equations. Now I'm going to solve this through the technique that we learned about earlier called the elimination method. So again, as before, step one is to solve for one of the variables in terms of the others, or in this case of the other one. Right? There's only two variables, so if we solve for A or if we solve for C, it's only going to be in terms of another variable. I will do one more complicated one later with more variables, and we'll see how we do that when we solve one in terms of the others, plural. But here it's just the other one. So I'm going to pick to solve the first one, A plus C equals 100, for A. So in other words, we're going to have here that A plus C equals 100. I'm going to subtract the C. I'm going to subtract the C. And I get that A is equal to 100 minus C. Okay? Beautiful. So now we know that we can solve for one of the variables in terms of the other one. And we've gotten that A equals 100 minus C. So I'm going to write that over here. A equals to 100 minus C. Now we're going to do step two. Step two is that we're going to now use this to eliminate A from the other equation. Okay? Right? So what we're going to do is we have this second equation, but instead of writing A, we're going to write down the expression 100 minus C. So step two. Eliminate in this case we're going to say eliminate A, right? So 5 times 100 minus c is or plus 3c equals 480. Okay, again, what we did here was we used the first equation to find out what a is in terms of the other variables. We then used this expression for a to substitute into the second equation. 5 times a becomes 5 times 100 minus c. And now we have this equation, which is only in terms of one variable, and hence we'll be able to solve it. So here we go. So this will be 500 minus 5c plus 3c equals 480. Okay, what happened here? What happened here was I applied the distributive law here. 5 times 100 is 500. 5 times negative c is negative 5c. Then we brought down our plus 3c, and then we brought down everything else. Okay, now we're going to combine these like terms here. You see? So we're going to have 500 minus 2c equals 480. Perfect. Now we're going to move the 500 to the other side by subtracting 500 on both sides. So minus 500, and we get negative 2c equals negative 20. We divide both sides by negative 2, we divide by negative 2, and we get that c is equal to positive 10. So we have just discovered that the number of children that were in attendance was 10. So if I was going to present this as my as a kind of homework, I would write at the bottom a sentence that says, there were 10 children in attendance. And there we go. A second example showing the utility of a system of linear equations, as well as the technique that we can use to solve a system of linear equations.